Hello everyone, my name is Zed Abulheja, and today my topic is about blockchain databases. So the reason I chose to talk about this topic for our database system course is because I've bought cryptocurrencies before and I never bothered looking up what a blockchain means. So I saw this as an opportunity to form an understanding of blockchains and know where my money is going into. So we're going to first talk about what is a blockchain. So a blockchain is a distributed database that securely records transactions, especially those made in cryptocurrency. So we've all heard about cryptocurrencies, about blockchains mainly through cryptocurrencies. Blockchains are composed of blocks shown in this picture, and each block contains a list of transactional data, and the blocks are linked chronologically, forming a continuous chain. Blockchains are maintained across computers that are linked in a peer-to-peer network manner. So now I'm going to compare traditional databases with blockchain databases. So traditional databases have a centralized structure and they're controlled by one single entity. On the other hand, blockchain databases are the complete opposite. They are decentralized and there is no central authority. So the decisions are made across a network of computers rather than being controlled in a single central authority like traditional databases. Traditional databases are flexible and scalable. We can scale them as we please. On the other hand, blockchain databases are less scalable than normal traditional databases, but they are secure and transparent, which in my opinion are the two biggest advantages of blockchains. So now we're going to talk about some use cases of blockchains. Blockchains were first mentioned in 2008 by a paper, which is called the Bitcoin White Paper, written by Satoshi Nakamoto. And later it was implemented when Bitcoin was released in 2009. So Bitcoin was actually the first ever use of a blockchain. Blockchains were created by Satoshi Nakamoto, and no one really knows who Satoshi Nakamoto is. He is anonymous. So fun fact is, no one knows who created blockchains. Other uses than cryptocurrencies for blockchains are supply chain management. So some companies have decided to use blockchains to track their products from origin to destination because some key aspects of a blockchain is transparency. So it can make that happen and it can ultimately reduce fraud in that company. It will also be used in healthcare to securely store patient records and ensure data privacy and integrity. It can be used in finance to manage and verify transactions because of data integrity, and it can reduce reliance on intermediaries. So, for example, if I want to send money to my cousin who lives in America and I live in Jordan, I can do that instantly, and I don't have to go to Western Union, and I don't have to pay outstanding fees. So, in my opinion, that's the best thing about blockchains. It could also be used in intellectual property. For example, if I decide to buy an NFT, which is a non-fungible token, I can, an NFT is a picture or a video. I own the copyrights to that NFT. And it can also, some countries have their land ownership records through the blockchain now. So if I want to buy land, I get that registered through the blockchain. Um, and if I invented something, for example, I can register that patent in the blockchain. Now I'm going to talk about advantages and disadvantages of blockchains. So some advantages are security. So the data is immutable, so they can't be tampered with, and they are obviously um they are they are encrypted. Also, transparency. So, for example, if I own an NFT and someone wants to know who owns that NFT, they can immediately know that I own it. So, if I, for example, buy a crypto, I get a copy of the blockchain, so I can know who really owns how many Bitcoin cryptos. So it's transparent, but also secure. Data integrity. So data is basically accurate and consistent. But some disadvantages, as we mentioned, scalability isn't as scalable as traditional databases. Complexity, it takes a tremendous amount of skill to implement a blockchain. And it isn't as easy as a traditional database. There are regulatory issues. So, for example, the government are deciding to govern blockchain, so they are mandating laws that makes it more difficult to buy into or use blockchains, unfortunately. So now we're going to talk about how blockchains work. So first of all, the transaction initiation. A user initiates a transaction. So, for example, a user decided to buy a, Bitcoin, for example. So as soon as that transaction is initiated, the transaction is grouped with other transactions, and when that to a block, and when that block is full, the block is created. And after the block is created, it has to get validated. So a consensus mechanism ensures that the transactions are valid and that the block is correctly formed. So after the validation, the block is added to the existing blockchain. So each block contains a unique hash that links it to the previous block, maintaining the integrity of the chain. So that's how a block is added into the blockchain. And finally, after the block is added, the distribution, so the updated blockchain is distributed across all nodes in the network, ensuring that everyone has the same verified version of the blockchain. Now to conclude my PowerPoint presentation, we learned that database blockchains offer enhanced security, transparency, and data integrity. While they are promising, they face challenges like scalability and complexity. So now I'm going to talk about the technical part. So I'm going to discuss data mining and show you, block mining and blockchains and show you how it's done. I'm going to compare the Bitcoin blockchain with the more advanced and newer blockchains like that of the Cardano cryptocurrency. And I'm going to give you more fun examples and show you how blockchains really work. Okay, everyone. So now I'm going to talk about a bunch of random topics related to blockchains and mainly in cryptocurrencies. Because obviously I'm not going to be able to code a blockchain right now. That is way out of my expertise. So I'd like to start off by talking about cryptocurrency mining. So crypto can be mined, and basically we already mentioned that the blockchain runs on a decentralized computer network, which is peer-to-peer. So when the computers on that network verify, process new transactions, new Bitcoins are created or mined. So the network computers, or you can call them miners, process the transaction in exchange for a payment in Bitcoin. So essentially, you can dedicate your PC or server. You can create one with a lot of GPUs, and in return, you help the blockchain by improving it and solving complex algorithms using the GPU, the processing power of it. And in return, you get payment in that cryptocurrency which you are helping process the transaction of that cryptocurrency. So for example, you can go into a random website right now and just start mining crypto. So you can use your laptop, for example, and dedicate the GPU and keep it overnight, and you'll get a random, a small amount of Bitcoin, for example. So obviously it isn't profitable because electricity is way more expensive than the return you're going to be able to get. So it depends really on the price of that cryptocurrency you're mining and the price of electricity and the power of your laptop, of course. So people who are big in mining in Bitcoin usually have a huge server with a bunch of GPUs, and they keep it running all time, and that would be profitable. So, as I mentioned, you can go to a random website and just try it out, mine a random cryptocurrency. So, for example, I heard of one which is, I'm pretty sure, Storm Gain. Anyways, I'm not going to do that right now. I don't have time for that. So, I'm going to talk about the transactions in the Bitcoin. So, each cube or rectangle you can see here is a transaction. So every, say, under a second, someone buys or sells Bitcoin in this case. So all of those cubes and rectangles, they form one block. So the block is actually all of that. And as you can see here, around every 10 minutes, a new block is created. So those are essentially the blocks. And those are the transactional data within the block, as we talked about in the PowerPoint presentation. So the average block time, as you can see here, is 10.6 minutes. Now, obviously, the newer cryptocurrencies and the newer blockchains like Cardano or Ethereum, for example, have way faster block time. So the transactions are way faster. Here, you might need an hour to receive Bitcoin. On the other hand, for example, Dogecoin, you can just receive it instantly. So it has to play, like, it has to do something with Bitcoin being a very old blockchain built in the C++ language, as we're about to see. So before cryptocurrency is created, a white paper has to be made, and this is the white paper of the Bitcoin version 0.1. So in the white paper, you're going to have to dictate the amount of um, basically um, cryptocurrency you're going to meant for that project. So in the case of Bitcoin, there's only 21 million Bitcoins in existence. And basically this has to do with something with mining. So obviously in the beginning there wasn't 21 million Bitcoins, and every 4 years mining gets twice as hard and half as rewarding as the 4 years before that. So as you can see here, in the first 4 years, there was 10.5 million bitcoins. Then the next 4 years, 5.2, and the 4 years after that is 2.6, and it goes on and on. So this is a white paper written by Satoshi Nakamoto, and this was the first ever mention of the blockchain, as we talked about. So a fun fact is the entire source code of the Bitcoin blockchain is around 7,000 lines of code, so it isn't that complicated. And as you can see right here, that's like the main um, class, and the code is written in an object-oriented way. So as you can see here, those are all the classes created for the first version of Bitcoin. And as some of you might know, Bitcoin is an open source, so obviously that is very different now. People can update the code and add code to it. So that's something very nice about Bitcoin, that it's improved over time. So that's the source code written in 2008, as you can see here. And there's the node, also class for the nodes, right here, the node.h and the node.cpp, as we learned in object-oriented class. So another thing about crypto is you can have a wallet, and that wallet is basically a hash address, as you can see right here. So this is a hexadecimal value, I'm pretty sure. So that's how wallets are, and you can have, and as we said, the wallets are transparent, and anyone can find out who owns that wallet. As you can see here, we can look up the Bitcoin address transaction, and the transparency is a big part of the crypto. So now they are coming up with new languages dedicated for the blockchain. So one of those are Solidity. So obviously, projects blockchains aren't coded in C++, but they all share object-oriented similarity with C++. So that's my presentation. Thank you so much for watching. If you have any questions, please comment, and thank you.